Alrighty, here we go, finishing up with the same diagram as on the prior pages, and this region down here is still area of A, so integral of negative A. First thing they're asking us, if the integral from 0 to 6, which is this entire section here, is negative 42, then what is the value of A? So let's first split apart this integral using our properties of integration. So we have 3 times the integral from 0 to 6 of f of x dx plus the integral from 0 to 6 of 1 dx. That is negative 42. So this integral from 0 to 6 of 1 is a value of 6 because it's a y equals 1 graph from 0 to 6. So that's 6. So I end up with my equation of 3 times the integral from 0 to 6 f of x dx equals negative 48. Divide by 3, and I have the integral from 0 to 6 of f of x dx equals negative 16. That's this whole section, but I know that this section here is negative 6. So this value of negative 16 equals negative 6, negative 6, actually minus a, because a is a positive number, because a is an area. So adding 6 to both sides, negative 10 is negative a, and guess what? A equals 10, the area. Remember they asked for area, so it's a positive number. Okay, next problem. If the function represents the velocity of a particle, how far would the particle have traveled on the interval from 6 to 14? Oh, excuse me, 13. So here's 6. Let's see. This section here will represent how far the particle goes to the left, or backward or down. So that is going to be a negative 2.5. Okay. And then let's see, 6, 7, 8, 9, 10, 11, 12, 13. So I've got the area of this triangle is 1, 2, 3, base of 4, height of 4. So this area is 8, 1/2 base times height. They want to know how far the particle traveled. This is a distance question, not a displacement question. So the answer is 8 plus 2.5, or 10.5. All right, the next problem looks like an FTC area accumulation problem. They say if little f, which is our graph, is the derivative of big F of 6 equals negative 2. That's our starting point. Determine the following, big F of 12. I'm going to erase what I have up here. So big F of 6 is our starting point. So little f of 6 is right here. And I'm accumulating area over to 12. So I already discussed that this section here is an integral of negative 2.5. And then to get over to 12, I need 10, 11, 12. I just need this section here. So this area is base of 3, height of 3, divided by 2, 9/2 is the area. So negative 2.5 plus 4.5, if I am moving to big F of 12, I am doing displacement. This is not total distance traveled. This is actually taking the integral. So negative 2.5 plus 4.5 is positive 2. Add it to my starting point of negative 2. So negative 2 plus 2 is 0. All right, f prime of 12 is the slope of this function, f at 12, and 12 is right here. So it's really asking for the slope of this line, and the slope of this line is 1. All right, the average value of little f here, remember that the average value of little f, let's write it out, the average value of little f on 6 to 12 is the dx is the same thing as big F of 12 minus big F of 6. So the really cool thing is divided by 12 minus 6. And what I did there was I took this equation here is the fundamental theorem of calculus, and I divided both sides by 12 minus 6. The really great thing is that big F of 12 and big F of 6 you already have. Big F of 12 is 0, big F of 6 is negative 2, so I'm going to go up here for C. I have 0 minus a negative 2, divide that by 12 minus 6, so I end up with 1/3. And then the average rate of change of big F, guess what? that is this half of the equation. Big F of 12 minus big F of 6 over 12 minus 6, so it is the exact same thing.